Hi everyone, this is Mrs. Trigno with page 5 of the Chapter 5 test review, number 1. This is just two problems, but they both involve graphing, which I know for some of us can be a little bit difficult, so I'll try to go through it as slowly as I can. Number 15, if I'm graphing this one, I notice right away that it's in slope-intercept form, which is a really nice way to be able to graph. I'm always going to start at my y-intercept, which is the last number here. It's a positive 1. And then my slope is 2 over 3, so I'm going to go up 2 and to the right 3 and put another point. Again, I want to emphasize your y-intercept is always starting on the y-axis. Your very first point will always be somewhere on this vertical line. I saw a lot of people in that quiz that we took over this stuff starting out on the x-axis. You are always, always, always starting on the y-axis with that y-intercept. Okay. From this point, I could go up 2 and over 3 again, if I wish. This one does have an equal bar, which means that I do need to draw a solid line through those points. And then this is less than, which means my shading would be down below the line. Okay, so those ones are pretty straightforward when they're written in slope-intercept form for you. Okay, number 16 is asking you to graph the system and identify the solution, which means we're putting two lines on the same graph, and the solution is where they cross. I have two separate lines here, just so you don't get confused. Okay, the first one is in slope-intercept form for me, so I would probably just start at the y-intercept, which here is -8. Should be 1, 2, 3, 4. -8. And then my slope is 2 over 1, which means I'm going to go up 2 and over 1. And I'm probably going to do quite a few points on this one, because these ones where you're looking for that point of intersection, it's really important that you have a nice straight line. If you wanted to use a ruler, you certainly could. Let's see, let's hope that'll be enough. Okay. Now the second equation is not written in slope-intercept form. So I have two different ways that I could go about solving this. I could put it in slope-intercept form. I'm going to do that off to the side here. So -3x plus 4y equals -12. If I wanted to move the x to the other side, I would add 3x and add 3x. So that would leave me with 4y equals 3x minus 12. Again, I put the x first so that it would match that slope-intercept form, the mx plus b. Divide every piece by 4, and I end up with y equals 3/4 x. And I'm leaving that as a fraction because that's going to be my slope. And then 12 over 4 is 3, so 3/4 x minus 3. That means I'm going to start at -3, again on the y-axis, and my slope is going to tell me to go up 3 and over 4. Well, that's convenient. Up 3 and over 4. So this line will look something like this. So my solution is this point right here, and the coordinates there would be 4, 0. And I could plug those two back in and check to make sure that it works in both equations. So if you were nervous about getting that one correct, I would recommend that. The one thing you don't need to do, that I do see people doing sometimes, is doing either substitution or elimination here. If I'm making you draw a graph, then the graph is going to tell you your solution. Now, if you wanted to do substitution or elimination just to make sure you got the right answer, that would be okay. But you don't need to do it to get the answer, because the answer will come right off your graph. By the way, if you had wanted to use your graphing calculator on this one, you would have also had to take this equation and put it into slope-intercept form. So in your calculator, you would have entered this equation, the 2x minus 8, and then the 3/4 x minus 3. Okay, one page to go.